In this question, we're told that data on alcohol-related motor vehicle crashes was collected from Kansas City over a 12-month period. The number of alcohol-related crashes for each month are provided in the table below. We want to use Desmos to calculate the skewness, determine whether the conditions are met to estimate the population mean, provide that estimate, and then interpret the result. To do this, we'll copy this given data, open this tool in Desmos, paste that information in for the data set in X1. We're skipping successes in this value for n. We don't need that information for this problem. But we do need to plug in that data and calculate the skewness, which is negative 0.4034. Let me double check because I think I already forgot that number. 4034, great. In part B, we're asked, are the conditions met to estimate the population mean? We're not going to go with this first option because our sample size is small. We only have 12 data values. But yes, even though the sample size is small, the data is approximately symmetric, so it is likely that it comes from a normally distributed population. In part C, we want to construct the 95% confidence interval estimate for this population mean. So where we have this conf level value, we'll plug in 0.95. We're estimating a population mean, so we'll click on this drop-down arrow, and we get the lower bound and upper bound. Our lower bound will be 55.7059. So inside a set of parentheses, we'll type in that first value, and then comma 62.7941. And we have our correct 95% confidence interval estimate for the population mean. Can we conclude that the average number of monthly alcohol-related car crashes in this city is greater than 58? No, not in this case because the interval contains values equal to or smaller than 58. Now in our next question, we're told that a recent study looked at the percentage of people in 15 different non-US countries who replied yes to the question, is religion important in your daily life? The resulting percentages for each country are listed in the table below, and we're going to repeat that same process that we did in the last example. We can refresh, paste in our data for X1, and get our skewness, which in this case is 1.22499. Then we're asked, are the conditions met to estimate the population mean? Our sample size is small, only 15. And in this case, no, the sample size is small and the data is highly skewed, so it's likely that it comes from a non-normally distributed population. We cannot estimate the population mean. In part C, we will still be asked to provide the 95% confidence interval estimate for the population mean. So when we click on the drop-down menu, let's see, we need the confidence level of 0.95. We see that we can still calculate this interval even though the conditions are not met. So this lower bound will be 36.0498. And then comma, the upper bound will be 67.9502. Oh, did I type that wrong? 9502. So in part B, we said the conditions are not met to estimate a mean, but then we went ahead and constructed this estimate. It is mathematically possible. There's nothing that prevents us from doing that work. We just have to know, separate from the tool just spitting out numbers for us, whether or not this interval is valid and has any meaning in terms of drawing a conclusion about the problem. Then the last part, we see that we're told that a recent poll in the United States suggests that 50% of Americans believe religion is important in their daily life. Can we conclude that the average percentage of people in other countries who feel similar is greater than 50%? We have a confidence interval estimate. We can compare it to that value of 50%. But again, because in part B, we said that the conditions were not met to estimate a mean, we just have to know to state that we cannot draw any conclusions based off the information available. Despite the fact that we have a confidence interval, it's essentially meaningless because the conditions for its existence weren't met. It's mathematically possible to calculate it, but it has no true meaning. There's nothing we can do with it to draw any conclusions.